All right, welcome back, fifth graders. We are here today to start day 2 of finding the surface area of a three-dimensional figure. And hopefully this page looks familiar to you since it's the same page we worked off of yesterday. If you recall, yesterday we took the time to work off of the nets. We didn't need to create any of the nets. They were already created for us, but we did find the surface area of each of these 3D shapes, a cube, a rectangular prism, and a triangular prism, by finding the area of each of their faces in that net. I would still recommend that to be the easiest way, and I'm definitely not going to tell you that you have to find the surface area in the way I'm going to show you today, but I do feel like there are a few of us in this group that are able to not have to create a net to find a surface area. And eventually, guys, they're going to want you to not have to create that net to find a surface area. So we're going to spend today, and hopefully this lesson will go a little quicker than yesterday's based on the fact that we know what surface area is, to find the surface area of these 3D shapes, a cube, a rectangular prism, and a triangular prism, without actually laying it out as a net. All right, so we're going to focus on the left side of our screen today. And as we look at problem 17 here, guys, we see that we are dealing with a cube, which is just simply another fancy term or a very specific type of rectangular prism. All right, and the best part about a cube, and the reason we're starting with this, is you can see that all of the numbers, the base, the height, and the depth or the width of this 3D shape are all the same number. They're just 8. Okay, so we have a very easy formula or a very easy process for finding the surface area of a cube because there are no number changes. There aren't any, well, how many of this do we have and how many of these do we have? You just simply need to remember how to find the area of any square and then how many faces or how many squares are we dealing with. So as we look at problem number 1 here, or problem number 17 as it actually appears on this page, we are going to find that we have a top face and a bottom face, okay, 2 there, a front and a back, and a right and a left. Okay, so 6 faces. And if I'm going to go over here just to check that to make sure with our net, we can see that we have 1, 2, 3, 4, 5, and 6 faces over there. So we are looking and dealing with 6 faces in any rectangular prism. Now the positive with this, guys, is like we said, we're dealing with numbers, so that are the same. 8 times 8 is going to be what we are focusing on here. And if you don't know what 8 times 8 is, or you're not sure about that, again, plenty of ways to check that. And remember, you do have the use of a calculator to figure this out. So that means every one of these faces, guys, is going to be 8 times 8. So 8 times 8 equals 64. And we just got done saying that we have 6 faces. So I can add 64 together 6 separate times, or I can take 64 and multiply it by 6. And this is exactly what I did yesterday, only I laid it out in our net and I showed you how and where those 64s came from. So as we look at 64 times 6, again, remember that you have the ability to use a calculator, but if you don't, you can simply go through the math and realize that this should get us to an surface area, of 384 square centimeters. And again, key part is the label. We are not dealing with cubic anything, guys. We are dealing with square area, because even though it is a three-dimensional shape, we are looking to how much area, how much surface is exposed to the outside, just the two-dimensional faces of these shapes. All right. Relatively easy one to start out with. The second one, not as easy. Now we really do need to, and I would highly recommend using a piece of scratch paper, guys. If you do not write out the net, like I still would suggest, if you are just looking at this, remember that every rectangular prism has 6 faces. Okay? And every one of these is going to have a pair or a match on its opposite side. So just like the cube up on top, it has a front and a back, a top and a bottom, a right and a left. Each of those are going to be equal to one another. So once I find one, I really only need to find 3 separate areas, and then I can combine them together. So as I'm looking at my 3D shape here, I'm going to try to find the front first. So I'm looking at 10, by 15, and I will be changing colors here again today, guys, just simply to get you to illustrate what we are looking at on each of these different sides. So the front of this rectangular prism, as is facing us, is going to have an area of 150 because that is a height of 10 and a width or a base of 15. So 150, and we know we will have two of those because we have a front and a back. So I will outline the front and then the back right back there. Those are my same 150s. All right, now I'm going to switch gears, and I'm going to go top and bottom next. All right, so now, again, sometimes even helps to draw these things out if you prefer to do that instead of just writing the formulas down. We have, if I'm rotating that shape or if I'm looking at that shape, we have a height of 7 and a length or a width of 15 again. So this is 7 times 15. So again, if you're not sure of 7 times 15, I'm just going to do the math here again. I did it yesterday for you, but it is 105. So that means we have a top at 105 and a bottom at 105 because the opposite sides of this rectangular prism are equal. So we have those there. And now we're missing two faces. We only have 4 of them, and we need to remember that every rectangular prism has 6 faces. So now we're dealing with the right and the left. Because the numbers are on the left, I'm going to start over there. Again, we're going to double up and use that number 7 for the height or the base. And then the 10 is the number connected with that there. So here on the left side, we are looking at 7 times 10, or 70. So for this left facing side and then the right facing side, which is equal, are both going to be 70. So here again are my 6 faces, and you can see by the colors how I've arranged them. The 2 blue ones are the front and the back, the 2 green ones are the top and the bottom, and the 2 red ones are the right and the left. Once I again take those and add those 6 faces together, I end up with 650 square, in this case inches, okay, for my answer, adding these 6 faces together. All right, now again, just like yesterday, and I'm going to erase some of this stuff so I give myself some more space. Just like yesterday, guys, this is definitely going to be the hardest of the 3. And that is because we are dealing with triangles. And so we've got one more formula to remember. Another aspect of this is that the 3 rectangles involved are not the same size. 2 of them are, okay, the 2 sides are, but the base is going to be a different measurement. But like yesterday, I'm also going to start with our triangles again. The bases will be the exact same size. They will be equal to one another. But remembering which numbers to use is important. Okay, remember that finding the area of a triangle is base times height divided by 2, or half of the base times the height. So if we are looking at the triangle bases, we are looking at 12 times 10, or 120, divided by 2. Okay, so each of those is going to be 60. So there's my 2 faces, my 2 triangular faces, or my 2 bases that we are dealing with, and those are both out of the picture. All right, now remember, this does not have 6 faces. This only has 5 faces because we have 1, 2, 3 sides on each base, and that means from those 2 bases we go up and have a face from each of those sides, which is 3 more. So 2 plus 3 equals 5. All right, now I'm going to spend time on the 2 that are the same again. So here are my 2 rectangles that are the same. We've got let me change the size of my ink here. Here's our right rectangle that is the same, and here is our left rectangle that is the same. So those 2 sides are the same, and they are dealing with the 16 times 13, 16 being the base, 13 being the height. So if again, come back up here, do the math, 0, 6, 1, so 8, so we're dealing with 208. So now we've got 2 faces, a right rectangle on that side that's 208, and a left one that's 208. All right, and then we've got that one base rectangle, and we can't call it a base because technically our triangles are our bases, but the one that's sitting on the bottom right now, that is different dimensions from the 2 on the side. And the reason it's different is we don't have a 13 involved, we simply have the 10. coming across here. So here is the 10 by 16, and there is only one of those rectangles. So instead of adding 6 numbers together for this one, we are only adding 5. And this one will total 160. Okay, should have shrunk my ink, but now I gotta wait for that to disappear. But as we're doing that, guys, just realize that I still recommend creating a net or drawing a picture of what this shape would look like in a 2D form, just like it is on the right hand side there, because I do think it's easier to still fill those spaces or to see how many we're actually dealing with instead of trying to visualize in a 3D situation that we are today. All right, just showing you the opportunity that you can do it that way. All right, so the numbers have appeared again. We are now looking to add these together. So 8 plus 8 is 16. Again, the 3 6s we have there is 18 plus 1 is 19. 2, 4, and 6. So 696 square feet. And again, guys, like I mentioned yesterday, the number one silly mistake that people make, you go through all that work of finding 3 different areas, if not more, combining all those areas together, and then you make the silly mistake of labeling it incorrectly. Remember, we are dealing with just the area, the 2-dimensional shapes on the outside of those shapes, so it needs to be labeled in squares and not cubes. All right, little shorter video today, guys. Hopefully you can answer the exit ticket. If not, please make sure you're asking questions of me, and tomorrow we'll have our last lesson on surface area.